Hi, my name is Catherine Andrews.
And I'm Elaina Kramer.
And today we will be guiding you through the process of integration in kinematics.
So let's first discuss when you would use integration. You should already have learned how to take the derivative of an equation, so now you need to know how to do the reverse. Integration can also be called the antiderivative because it does just that. It takes a derivative and it returns it to the original equation. You can use integration on a first, a second, or a third, really infinity derivatives. You might already know that integration is used to find the area under the curve for an equation, but it is also used to find the speed, acceleration, distance, and velocity.
First, we will view what it looks like to integrate from velocity to displacement, also called position. So let's say you're given a problem like this. A particle moves in a straight line. Its velocity, vms to the negative first power, which stands for velocity, after t seconds is given by v equals 6t minus 6 for 0 less than or equal to t less than or equal to 2. After p seconds, the particle is 2 meters from its initial position. Find the possible values of p. So, what do you do first? Well, the first step will be to identify what the problem is asking. Or in this case, it's asking you to find the initial position of p given its velocity, meaning we need to integrate. So with this problem, the first thing we need to do is isolate the equation given, or v equals 6t minus 6. Now we're going to set up the integration problem. The equation will be equal to 2 because we have our 2 meters, and we are going to be integrating from p to 0. So now let's put our equation into our integration. 6t minus 6 dt. Now with integration, this becomes 6t squared over 2 minus 6 times p. Let's write that a little bit nicer. Now we have 2 equals 3p squared minus 6p. Because this is integration, we already know that we have to take that 2 and put it on the bottom, and whatever is on bottom goes up to the top, or otherwise known as the opposite of derivatives. And same thing, we're going to multiply that p in instead of making it go away like we would in taking a derivative. Now going down to this equation here, we still have to find our p value. So let's turn this into something we're a little bit more familiar with. How about a quadratic? 3. So now we have 0 equals 3p squared minus 6p minus 2. Putting that 2 on the end to get that quadratic. With quadratics, what do we always know we have to do? Yay! Quadratic formula! As we all should know, the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. With this, we're now going to insert our numbers given into our quadratic formula. So this becomes 0 equals 6 plus or minus the square root of 6 squared minus 3 times 2, negative 2, my bad, all over 2 times 3. Although the quadratic formula does say we need a negative b here, because this number is negative 6, this will be a positive 6. Simplifying this just a little bit more, we're going to change this into 6 plus or minus the square root of 36 plus 24 over 6. We're going to keep simplifying, and we are going to change this into 6 plus or minus the square root of 60 over 6 And now we're going to change this into two separate equations so we can get those p-values. So we need one for addition, 6 plus the square root of 60 divided by 6, and 6 minus the square root of 60 divided by 6. Using a calculator, you will find that p equals negative 0.29, or p can also be equal to 2.29. All right, now with our p-values, we have found the position or displacement of our original problem from velocity. So let's recap one time. We started with our velocity equation. We took the derivative. We took the integration or the antiderivative. Don't get confused there. It very is confusing. After we have that integrated equation, it should give us a quadratic, which we can then take the quadratic formula for, which will bring us all the way down to our new position or displacement. Because this is a position on our graph or in some place, some space in time, because we're working with particles, this means that it is okay to have a negative number. You're just starting at a negative position. And because our initial problem said it wanted the possible values of p, it is very much okay to have two different values of p. Just make sure you highlight both of them as your answer.
So now that you have found velocity to displacement, what about finding velocity from acceleration? We can still use integration from acceleration to find velocity. It's simple. Not only does this apply to velocity and acceleration, it also applies to the other equations of motion. So we've already talked about the other differentiations and integration. So here's a little chart to kind of keep it all in order. So just to review, when you're differentiating, you could take displacement to velocity, and then from velocity, you would differentiate into acceleration. Whereas when you're integrating, you would take acceleration and differentiate into velocity, and then velocity and integrate into displacement. So if you want to write down this chart in your notes just to keep it all straight, I'll let you go ahead and do that now if you want to pause the video. And by definition, acceleration is the first derivative of velocity with respect to time. Alright, so now let's suppose you were given an acceleration equation and you needed to find the velocity. Here will be our example problem. So the acceleration of a body traveling in a straight line having a displacement xt m from an origin is governed by this equation right here. So the acceleration equals 6t minus 2, where the derivative equals 0 and x equals 0 when the time is at 0. So don't let this ending part confuse you. It's basically just saying that at the origin, the time and the x are equal to 0. So the equation is going to ask us to find the velocity after 5 seconds. Alright, so let's first set up the equation so you can show that you're going to be solving for velocity. So if you want to go ahead and pause the video and try to set up the equation, go ahead and do that now. Alright, so to show that you're solving for velocity, of course, we're just going to put v to the t for velocity equals the integration of 6t minus 2 dt. Alright, because we are finding the antiderivative of the equation, we need to try and put it back into its previous state. We know that the derivative of 3t squared is 6t, so now we just need to get the rest of the equation into the same format. So, when we do that, we're going to get 6t squared divided by 2 minus 2t plus c. And don't forget to account for your constant variable c right there. Because when the original derivative was taken, any constant variable you would have had would have been eliminated. Because of that, we'll use c as our placeholder for the possibility of any lost constant term. Okay, so now let's reduce that equation to velocity equals 3t squared minus 2t plus c. So now that we have our simplified integration equation, let's look back to the original equation. The problem states that when d of x over dt equals 0, and x equals 0 when t equals 0, simply meaning the initial point t and x are equivalent to 0, we can plug, so this means we can plug 0 into the value t in order to help us find the constant term c. Don't forget, we need to find this constant term c to actually find the original equation. Alright, so go ahead and try to set this up. You want to pause the video now, you can. Okay, so you should have been able to set it up so that v of 0 equals 0, and therefore that would mean 0 equals 3 to the 0 squared minus 2 to the 0 plus c. So you probably can already see that these are all going to cancel out and just turn into 0, which means that c is equal to 0, and therefore we don't have a constant term in this problem. So we can eliminate the variable c from our equation and focus on just finding the velocity. So let's plug in our variables now. Don't forget that we're finding the velocity after 5 seconds. So now that we know that the c is not in this equation, we'll plug in 5, so that 3 times 5 squared minus 2 times 5. So hence, if we go ahead and plug this into your calculators or just do it in your head, the velocity at 5 seconds is 65 meters per second to the negative 1. Alright, and so this value that you found is your answer. So you just found the velocity after 5 seconds. Okay, hopefully this helps. We just showed you how to integrate and when to integrate.
This has been Catherine Andrews
And Elaina Kramer.
Have a great day. Hi, my name is Catherine Andrews.
And I'm Elaina. Just Elaina.
Oh shoot, it's already recording.
We can...
And today we will be guiding you through the process of integration and kinematics.
Still kinematics.